Hey guys, in this video we are going to review a variety of vocabulary terms that are used with circles. Some of these will be familiar, some of these might be a little bit new. It's really important because there's about 15 to 20 terms that we're going to learn, and they have very specific differences and very small differences. So that is why we're going to go through this video just to learn the vocabulary and practice identifying it a couple of times. So to start off with, we're going to talk about a circle. And a circle is the set of all points in a plane equidistant from a given point. So equidistant, right, that means the same distance away. And you might be familiar with that if you've ever drawn a circle with a compass, right? You have 2 points that are a certain distance apart and then you just spin it around and you get everything. You could also look at it from the equation of a circle. Now, this year we're not going to get to go into this too much, but this right here is our equation of a circle. And if you look at it, it's very close to our distance formula, right? The distance formula is the square root of x minus, you could say x1 squared plus y minus y1 squared. And that's our distance formula, which is also, when we learned that, we saw that it came from the Pythagorean theorem. And the same thing happens here, right? We're looking for the distance from HK is actually our center. So we're looking at the distance from that point HK, and that's going to be the same all the way around, and that distance is actually our radius. So the only reason I want to say that is that the equation of a circle makes sense because it's just telling us, hey, if we know what the distance is to all those points, I can give you any point by just telling you the center and the distance. Now, we know a radius. A radius is the distance from the center to any point on the edge. We know that a radius could be drawn any way that we want, and it's always going to be, they are all going to be congruent to each other. So if you know the radius in one spot, you know the radius in another spot. Our diameter is a chord that passes through the center of the circle. Now, a chord is a line segment whose endpoints lie on the circle. So it has to be a line segment. It cannot extend past that because that will be something else we will talk about in a minute. And our diameter is a special type of chord. Our diameter is in fact the longest chord that you can make, right? And it doesn't matter if you draw your diameter that way, or if you draw it that way, or any way that you want to do it. All of those will have the exact same length, and they will be the longest chord that you can possibly make. If you tried to draw anything longer, it would be going outside of your circle. Now, we're going to skip and go to actually secant first, because secant is very closely related to a chord. So a secant is a line that intersects with a circle at exactly 2 points. So you could think of it as if you took a chord and instead of it being a line segment, turned it into a line, you would have your secant. Now, because secants are lines, they have an infinite length, whereas a chord has a finite length. And it has to intersect at 2 parts. Your secant could go through the center, but it's still not a diameter because the diameter is only the chord portion of it. Remember, the diameter has a finite length, so it can't be a secant that goes farther. Or we would have to be specific what terms we're using. Then we have a tangent line. A tangent line is a line that only intersects at 1 point. And you could have a tangent that looks like this. Maybe it's a ray or a line segment, but it does touch at exactly 1 point, which we call the point of tangency. So that would be that point right there. Now, if you've ever heard the phrase going off on a tangent, that means that you're kind of related to what we're talking about, but you're a little bit going away from it, and that's what our tangent line does. It just touches our figure. And we would say that it intersects at exactly 1 point because there is a point that they share. Even though our tangent line doesn't actually go through the circle, it does touch it at 1 point, so we call that an intersection. So now that we've talked about some different types of lines and segments, we're going to talk about our arcs. Now you guys know that the circumference of a circle is the distance around the circle. It's like the perimeter. An arc is just some portion of that circumference. So some part of that edge, it could be small, it could be large. We label arcs like this. So it looks like a segment, but then you have a little curve symbol on top to show you an arc, and A and B are the endpoints of that arc. Now arcs can be split up 3 different ways. A minor arc is less than a semicircle, so between 0 and 180 degrees. A major arc is more than 180 degrees. And then a semicircle is exactly 180 degrees. Now, when we're naming arcs, you notice that in this circle, it has a minor and a major arc labeled with the same points. So our minor arc would be arc AB, and then our major arc would be arc ACB. So it's telling you you're going from A to B, but you're going to hit point C in the middle. So we have to put that point C in the middle to tell us we're going to take the major arc. If you only have 2 letters, it has to be the minor arc. But you could, if I had, say, a point X over here, you could have arc AXB, and that would be a very specific way to name the minor arc. A semicircle is exactly 180 degrees. It is an arc whose endpoints are the endpoints of the diameter. And then we've got some different angles. A central angle is an angle whose vertex is in the center and the sides are radii. Now that is very interesting because we learned central angles when we learned about regular polygons. Because the regular polygon had those radii that were from the center to a vertex, and the vertex lied on the circle. So we were actually just talking about the central angle of a circle. So our central angle is just from the center to a vertex. And that is different from our inscribed angle. Our inscribed angle is all the points are touching a circle. Like our inscribed figures, it is when the vertex of that angle also lies on the circle. So you notice our inscribed angle actually separates our figure into 3 arcs, 1, 2, and 3. Then we have congruent circles. They have the same radius or the same diameter. It's 2 circles that are the exact same size, but they might not be in the same spot. And then we have a sector. And a sector is a portion of an area formed by the central angle and its corresponding arc. So if I have this central angle and this arc, that is a sector. You could also have this central angle and this arc. That's also a sector. So sectors are forms of areas. I like to think of a sector like the slice of a pie. And next week we will be talking about how do we calculate the lengths of our arcs and the areas of our sectors. Thank you.